very easy to install and set up programs. In other words, it makes it very easy to set up what's your computer environment, your computing environment. And it allows you to set up computing environment to run a program, or more technically, would say like run a task. So this is actually like very important, right? Like I think we said 35% of programmers said they use Docker in Stack Overflow survey, placing it above AWS and even like a Mac. So it is used all the time. Why is it important just being able to set up your environment? One is, like there's this software called Ghost, which is a blogging platform. It's basically a professional level blogging platform, and it is open source. Like we can use this thing for free. The issue, like the time, would be getting this thing set up on your computer, because if you think about it, well, one, you'd have to make sure that you have this thing uses Python, I think. So you have to make sure the right version of Python is on your computer. You have to make sure that you have the correct database set up, right? Like if you don't have Postgres installed on your computer, it's just going to break. You have to make sure that you have the right front-end software, meaning, all the animation and things like that. So that would probably be some version of React, and React probably also uses like Node. So we need to make sure that's correct. We need to set up any of our environmental variables, right, to make sure this works. And we have to do all of this without making any mistakes, right? Like making sure that we're setting up the correct version of Docker and that, it's connected and things like that. So, getting all this installed, doing it without making mistakes, right? Like as we kind of know, because we've gone through this course, well, that takes a good amount of time, right? So if there's a way to automate all of this and make this easier, like that would be really nice. Another reason, so one thing is just getting complex software set up locally on our computer so we can begin development. Another reason why Docker is very popular is because of the modern development workflow, and that is to try to really move your code into production as quickly as possible, all right, and pretty often, meaning maybe once a week, every couple weeks, you'd want to move something you're working on in development into production so that the end user can see it. Why? Because the idea is, a product manager has an idea as to what they think would improve the product. We want to run that experiment quickly and be able to, get that feedback very quickly. So the modern development workflow is, okay, we code in development, and then pretty easily we should be able to push our changes to production. Now, things that can go wrong, right? Like, it's a mess if something works locally, but then it doesn't work on production, right? And reasons why a bug can occur, why something might work on your computer but not work in production, is because the production environment is different than the development environment. For example, if you're using a different version of Postgres or some other database, it's not uncommon to have like Redis or other types of databases, Mongo, also being used, and say you upgrade the version locally, and therefore your code works for your local version of Postgres, but not the one being used in production, right? Now we have this mismatch, and debugging that is, one, a mess, and two, right, it would cause issues on the website. It would be a bad user experience if in certain pages may not work at all. So we really want a way to be able to make sure when we're developing software and setting up our environment, that then we can automate that same environment being set up on Amazon, right? So that we can make upgrades, like install the latest version of Postgres, and then make sure that, okay, production is doing the same thing, also has that latest version. So this is what Docker will do. It will automatically set up our environment. And that goes beyond, like, people oftentimes ask, well, how is this different than, say, like a pip package, right? Installing those packages. Well, that's just Python, right? But it's not specifying the version of Python, or it's not specifying Postgres itself, right? Or it's not specifying Mongo or any other databases that we may need to use, or React, etc. Other pieces of software that we'll need to set up. And here's just, pushing to Amazon. So two kind of examples is, one, right, allows us to get stuff set up locally to then begin on development. 2, right, allows us to quickly mimic our development environment, if not replicate it, also in production. The other thing I should mention is we want everybody's development environment to look the same, meaning there's 30 developers here, right? We don't want one person using one version of Postgres and another person using a different version of Postgres. Because then, like, how's it going to work? We're all writing code that only works on our computer and not working off a common environment. So we need to be able to upgrade and change our environment and then have that duplicated across developers' computers and in production. Yeah. So this is like very, right, that you can see why. I hope you can start to see why this is such a popular tool, because it used to just be somebody's job to like run around and figure out why your environment is not working the way another developer's environment is working. Okay. Cool. Okay, so let's start using Docker. Yeah, I think we can just start using it. So what I did, you can use this from the command line. I think, let me make sure. I can just type in Docker and make sure that it is running. I'm looking for, which maybe it's not. Yeah, I'm looking for this thing right here. It's like a whale that has, these are like little shipping containers on it. And I don't need that interface. I just need this thing to stop moving. And that means that's loaded up. Okay, and then you can see I can type in the word Docker and kind of get started. What we want to download actually is Ghost. Hold on, I just forget the version I need. So, why Docker? Is this it? Nope. Sorry about this, gang. Let me just pull it up. Okay, Whirlwind Tour. Okay, so this is it. Docker pull Ghost. Okay, so what this will do is essentially download the blogging software, right? I already have it downloaded on my computer, but imagine, right, we want to download VS Code. And again, we will go through these concepts more than once, but this is my Whirlwind tour, right? So we want to download what's necessary for this blogging software. This is called downloading an image. And then the next thing we can do is actually run that image. So again, if you think of like downloading, VS Code, and now I want to double click on it and boot it up. So to download it, we just did this Docker pull command. And again, we'll go through this all again. To boot it up, we're doing Docker run. Notice what happened. You can start to maybe appreciate some of like the setup that's required to run this, right? It's creating a bunch of tables. It's booting up our local development server, right? It's setting certain permissions, right? Setting certain permissions. Now it says finally the database is in the ready state. It seems like there's some sort of scheduler involved in here, but somehow this seems to be working too. And it tells me, it's lying to me, but it tells me that the website is available on localhost 2368. But for whatever reason, this is not working, right? It turns out what I have to do, and we'll talk about why and how to do this, is I'm going to have to set a flag that says, okay, Docker is kind of running its own little world. It's running Ghost in its own segmented spot. And I'm going to say, I want to connect it to my host port, the port, and we'll talk about what host means, but to the host port, and we can just give it whatever port we want that's available, 8888, and connect that to where the website was running, which is 2368. And now, ultimately, if I click on it after it boots up, hold on. Am I lying? I may be lying.
Yeah, 888.
Oh, am I using it? Let's do the same one. I'll do 2369. That's fine. Oh, I see what you're saying. You're saying I should have gone to 8888. 2369. Let's go here. Yeah, there we go. Okay. So now, right, for whatever reason, we have Ghost booted up. So, this is just to show the value proposition of Docker, which is that we can easily, or somewhat easily, right? If we have this software, we can, I guess these pages aren't set up, but we can, install some relatively complex piece of software, right? That including the database, including, right, all these table setups, including this scheduler thing, right? It does work. And as we'll see, we can even develop further from here. Okay. Of course, like we kind of now have a bunch of questions, which is, all right, why did we have to do this step of it feels like we couldn't access this, what's called a container, this piece of software at first, but then when I did this mapping, right, then I was able to access Docker. We talked about this idea of like an image, right? When I did Docker pull Ghost, right? That was me downloading an image. So we have to talk about what that is. And then when we booted this up, this is called, actually running the software is called a container. So we'll have to talk about that too. All right. So, we still have to figure out a lot about Docker, but, in terms of just the use case for it, the idea that we can get this website up and running relatively easily is great. All right. Let's start to just dive into some of those components. So that is why Docker. Okay. So here I just want to talk about like how Docker works, right? And I think that will help to explain a bit of some of the underlying concepts. All right. So before Docker existed, back in the olden days, people would just use a virtual machine, okay, if they wanted to set up software. So why would they do this? The idea is if I want to prescribe, how I can get a complex piece of software to work and be sure that it's going to work, we can just start from scratch. So a virtual machine, you see here we have Windows, right? And and this Windows is installed on a Mac computer. So it's like I can, start up a fresh copy of Windows and then start to just install pieces of software one by one. And just as long as I follow those steps exactly, eventually I should get my software working, right? Because we kind of designed everything from scratch. Okay, with this virtual machine, just some terms, the Mac computer, right, is the host. It is, what's directly interacting with our hardware, with our computer. And then the guest is the Windows virtual machine, right? It is a guest of the Mac computer. Okay, so host is the Mac. It's directly interacting with the hardware, and then with this virtual machine, this is our guest. So we could have stuck with it, right? We could have just stayed with virtual machines and I guess followed the instructions to get a piece of software installed. But there's a couple issues. One problem with this is just if you think about time it takes to like boot up a Windows every time. A Windows operating system every time we want a separate piece of software running, right? Like that's pretty annoying. And then it also takes a good amount of space to do this. So what I mean by that is, we have this Ghost piece of software and say we used a virtual machine for this to boot this thing up and then host it on Amazon or something like that. We may also want, say, like a chatbot, right? Or like, so that people can ask questions. And we may want that on separate virtual machines to keep that isolated. So to do something like that, right, to have a whole separate Windows to make sure my chatbot is working and to make sure that my blog is working, that seems like it's too much overhead, right? It's like, yeah, we can make sure the chatbot is working by installing it from scratch and starting with Windows, and we can do the same thing for Ghost, but to have two separate virtual machines for each running task, it seems like overhead, right? At the same time, it is safe, however, because we know that we will not have anything on this blog, that any software on the blog that then is going to cause an issue with our chatbot, right? So we can be safe that way. It just feels very inefficient, all right? So kind of the goal of Docker is to be able to achieve that level of isolation so that we can run separate applications and they're not going to cause conflicts in terms of this one needs Postgres version 1 and this one needs Postgres version 2, right? Or this one needs Python version 3.9 and this one needs Python version 3.10. So we want our application environments to be separate from each other, be isolated from each other without having to take up all that space to do so. So, right, this is the promise of Docker: create an isolated environment while limiting the speed and space requirements of each environment. So, how does Docker achieve something like this? Okay, so the whole goal, right, have an isolated environment for each task without creating a separate virtual machine. It takes advantage of a technology in Linux. This is called the Union File System. Okay, so let me kind of explain what this thing is. So back in the days of CDs, right, you would, pop the CD into your computer, and it would appear, right, that this CD, we could make it appear that this CD is located somewhere it's not, meaning like under a common folder, under a common hard drive folder. So you can see I have that image here, that this Chamber of Secrets book is located under this Harry Potter books folder, right next to the Sorcerer's Stone, even though it's located someplace else. So that's like the first step of a Union File System, is just this trick that we can make it appear that a folder is somewhere it's really not. The other thing, this is a little bit more interesting. This is this copy on write feature. So let's say, I borrow Chamber of Secrets from my friend, right, the CD, and I decide to make some edits to it. All right, so I want to change the first page. Okay, what it will do, what the Union File System will do, is not actually change page 1. Okay, it won't let me do that. Instead, what it will do is it will make a copy of page 1. It will see that I'm trying to change it. So make a copy of what I'm editing, and then have this edited version kind of layer on top of the original, right? So I will see page 1, and I will see my edits. However, my friend's original CD will remain untouched. So you can imagine how something like this is important with software, right? If a piece of software, say both are using Python version 3.9 or some library in Python, but for one piece of software, say my chatbot, I need to edit, right, this library, I can do so. And what it will really do is just make a copy of that piece of software, and then have that edit, but will not touch the original. Okay, that's the idea. It will, every time I make a change of something that's shared, it will copy it before writing to it, right? So that's the second feature of the Union File System. With Docker, and let me just say this. So, okay, Union File System allows computer contents to be seen under a cohesive directory, even if they live elsewhere and used by another resource. The contents are read-only. Any changes made are performed by first copying the relevant file and then making the edit. So you can see this, I think, when you all pull a library. Let's just see this. Docker pull ghost. Yeah, it doesn't give a great example in this case, but lots of times what it will do is it will tell you, it will kind of pull down these different underlying pieces of software. Like maybe Ghost needed Postgres, and it needed Python, and it needed whatever, React. If those layers, if those softwares already exist, it won't repull them, right? Instead, what it will do is share them, right? Like we said with the Union File System, it can have it appear to live in the correct folder, even if it lives elsewhere. And then if there's any deviation, it will just have it will just have that layer on top that's altered. All right. And if you make any changes, it will again copy it and then write to that copied file, not alter the original. So the benefit of this is that we can really share a lot of the same underlying pieces of environment, yet make sure one piece of software doesn't alter or conflict with another one. Okay, so that's the underlying files, right? We can share them, yet make sure any changes to one doesn't affect the other. So that's the underlying files. The other thing is just the underlying processes. This is done with something called namespaces. Namespaces is a very easy concept. The idea here is, say I have my chatbot, which is using, like say it's using port, 8888, and then I also have my website. And the developers say, in Flask, they also, for whatever reason, specified to use port 8888. This would cause a conflict, right? It would say, hey, we're both using the same port. That is, going to break. So instead with namespaces, it just puts these under a folder, right? So really, when you're using port 888, you're using port 888 under this containers folder, under the chatbots folder. And when this thing's using port 8888, it's doing it really under a website /8888. This is the reason why when I booted up Docker originally and I ran it, let's do it this way, and I did Docker run Ghost, it said it was running under it was on port 2368, but it wasn't, right? It was under port 2368 in this running container, inside the folder, not actually on my laptop computer, right? This thing was untouched, all right? So that's the other way it maintains isolation of processes, right? So we talked about isolation of files. This is how it maintains isolation of processes by just using this thing called a namespace. Namespace is really just a folder, okay? So now, what is like an image? An image is these layered file systems that we're talking about, where two different images, right, my website and my chatbot, can both share these underlying files, pieces of software, right? And when there's a deviation, one will have something slightly different, all right? And then finally, when I boot up, actually start running my website, that's actually just a writable, that's just using that same union file system. Like for example, if I start changing Ghost, right? And I, add it, create a new author, create a new blog post, and then I shut that, what that's doing, that's not changing the underlying image unless we, automatically. All that's really doing is changing this top layer, right? And if you shut down, you'll see this, that if you shut down that container, this top layer will disappear. And that's done by design because that way we're making sure we can rely on this image, that nobody has made any alterations to this unless we we'll see ways to really kind of save our changes. But it's a kind of a good thing that we can rely on this underlying software. All it's doing is just never changing. When we boot up a container, we're never changing any of the underlying files. We're only layering something on top. When that container goes away, as in we press Control C, this thing disappears. This top layer disappears. And we start all over again, booting this thing up to here. Okay, so that's our container. Container is really just allowing us to make any changes, but those changes are not persisted. In the analogy that you can always use of what's an image, what's a container, just think about downloading any other pieces of software, right? I download Chrome, that's just downloading the files, right? That's the image. But booting up Chrome, right, double clicking on it and running it, that's running the container, okay? Here I talk about namespaces. So those are the two things, right? It's like this union file system. That's kind of, this piece of technology that makes us, gives us the ability to share software because I can have this software appear like it lives in different folders, right? One lives for the chatbot, one lives for the blog, but really it's shared amongst them, right? And then the second thing is if there's any change, right, to one of them, we're really always just copying it and then making the change. All right, we're not going to, anything that's shared, we're not going to affect the other guy because we're not actually altering it. We're just going to copy it and then make a change. Okay, so this is achieving our goals of appearing, isolation while saving space. Yeah? How did that sound? Okay, so now we can kind of just, go ahead.
Yeah, about the two different instances that could be running two different versions of something. To be clear, they're not running at the same time, or are they running at the same time?
They can be. You can, right? You can run, this comes up with namespaces. right? Where I could do Docker run, my chatbot, and that might run on port 8888, and the other one would be Docker run the blog, and that could also run on port 8888, and also it could share the same, some of the same underlying software too.
Okay, so if I think of it from a threading standpoint, they are like actually running parallelly. Like that's actually possible under this.
Yes. Yeah, absolutely. Other questions?
What about the container port? One is the host port and other is the container port.
Yeah, okay, that's a good question. So let me show. So really, if you go back to this image of the virtual machine, when you run something in Docker, you can think of it as running inside that, it's not really a virtual machine as we know, but inside something isolated, right? So what we're doing, when we kind of just say Docker run, and it says it's running on 2368 or whatever, it's running here, inside the virtual machine and not exposed to the host, right? The process's port is not mapped to the host machine. So what we have to do to access it, and we'll see this in a later lesson, is we can do this -p flag, and then we'll say I want to map my host port, and you can choose anything that's not running. So 23, let's just do 70. Map that host port on Windows to the guest port, right? And host port on Mac to the port of the container. So that would be this 2368. Okay. And now if I go, I'll have to go where? I'll have to go to 2370, which links to 2368 in the container. That's what I think it was Lei who was pointing that out. Okay, so I'm going to 2370 on my host, which goes to 2368, and that's kind of the portal, right, to where this website is running. Okay, so we can start to, when you're in terms of how to work with Docker, there's different, basically you want to think of it in terms of the resources, right? If I just type in the keyword Docker, there's two different resources that we'd worry about. One is an image. I guess actually I don't see it here, but you can type it in. You can just do Docker image, okay? And then you can see the different things you can do with an image. And then the other one is the container, okay? So with an image, the first thing is just like pulling down an image. So you saw we can do that with the Docker pull, and then you can, like, how do you know what images to pull down? Like for instance, Docker, let me see, there's a thing called Docker Hub, which hosts different images, the same way GitHub hosts different repositories. So I could do Docker Hub, probably Ghost. Right, and then here you see the official image, and now I'll click on this, and then from here, right, it just tells me this is the same way we saw for git clone. Here we see, okay, if we want to pull down Ghost, you just do Docker pull Ghost. The only reason why I did a special version. I'll show you that. I did this version 4.8.0 because I know it works on my computer. With an M1 Mac that uses like a different chip, anyway, there still can be some complications. Okay, so this is now, so we saw the first command with images is just to pull it down. So Docker pull and then the image name. You can do this for anything. Like let's do Docker Hub Python if you wanted to, or yeah, like you can download a version of Python. It's kind of weird to think about, but in Docker, right? So now I'm downloading Python. You can see right here those different layers. What are those layers? Well, maybe there's some sort of underlying software, like maybe some version of Linux that's being installed. This could be some, installing certain packages like the apt-get thing or whatever, right? And then finally we have Python installed. Then I can do docker image ls. This lists all the images, okay? And then you can delete them. You can do docker image, oopsies, docker image rm and remove Python, I believe. Right, and this should, you can see this, so it deleted these things. Okay, it's only, and it's going to keep, these are all underlying pieces of software. Some of this could have been shared maybe by Ghost, right? And we know that if this is shared, it's not going to have two versions of it. For example, if it had, the same version of Linux was used by both Ghost and Python, it would really only have that software downloaded once. Okay, so that's working with images. I don't know that there's too much more to doing that for right now, right? Or you saw we can, kind of download an image with this Docker pull followed by the image name. We can then list our images with Docker ls, right? List all of our images. Oops, sorry, Docker image ls. Right, list all of our images. If you want, you could see like more details about an image with like this Docker image history, and then I think like maybe the name, the image ID. See this? These are all the steps to building this host thing. It's like adding a file, adding the bash command, setting an environmental version for Node, setting a yarn version, up to finally running. This is actually running the website, the Ghost website, right? So this is just to see more details about an image. And you can see I'm using the image ID, which is just a more specific identifier of the image. So that's that about the image. The next thing is just containers. You can see if you do Docker container ls, this will display all the running containers. Right now we don't have any, okay? But if I do Docker run, this is how we'll boot up a container, the same way of like double clicking on a piece of software. And I'll do, let me first see my images again. So I'll say I'm going to boot up Docker run Ghost version 4.8.0. So you can see that to run a specific tag, like a tag is basically a version of the software, I put the colon here, and then I just do Docker run. Once I do that, if I do Docker PS, notice that now, or I guess the better way to do this for you all is Docker container ls. Notice that now when I list my containers, I can see that we have created a new running container. Okay, and the containers ID is this thing right here. So this is like the instance of Docker running. And normally you also get a name for it. Here it is, Pedantic Maxwell. If we want to, if we wanted to, we could have two versions of, just the same way I can have Chrome running twice on my computer. I could also do Docker run Ghost again, 4.8.0. And now I have Ghost running twice on my computer. And because of that, if I say Docker container ls, we see we now have two containers running on my computer. Okay, the same way I can have Chrome running twice on my computer. Notice this one is up 7 seconds ago. This one is booted up 57 seconds ago. And they both are given two different names. I can shut either of them down by pressing like Control-C, or I can shut it down by doing Docker stop and then the name of the container. So this will destroy this one, the one that was most recently created. It seems to have worked. If I look over here, this thing is now shutting down. Okay? So this is like me shutting down that version of Chrome. And then like we talked about, right, this container is isolated. So if I try to access it, I cannot, right? The only way for me to be able to access this, right, what I have to do is do Docker run -p, give it this argument of -p. And generally you'll see kind of what is the port that it's running on inside the container. And but the first argument is actually your host machine. So on my laptop, I want to map port 2369 to 2368 in the container. So it goes the host port, my laptop's port, to the port in the container. And now if I click on this, right, I have to change it to port 2369, and then I can access it. All right.